Hey, Mike here. So this is about 2 hours, 20 minutes after I first started to run this thing, about 2 hours after I did the last video. So we're in a position right now. We're not moving a lot of heat anymore. You see that first value there is -20. That's the suction temperature. Second value there is subcooling, 84 degrees. Third value is coolant temperature, 16 degrees. And the final value is the air temperature inside, just under the freezing point of water. A few minutes ago, it was in the high 20s, but we are not moving a whole lot of heat here. And the reason is the evap is frozen up. My coolant in there isn't a very strong solution, and it tends to freeze up. So I need to get some propylene glycol and get a appropriate mix made. Probably I want to do another test before I tear this thing apart and change anything. I'd like to mess around with this setup. I think there's some value here. So in the previous video I was talking about how it was moving a pretty good amount of heat. About 2 amps was the draw on the compressor, about 1.5 amps now. Really not proportional to the drop in the movement of heat. I'd like to explain a little bit why to anybody that's not that familiar with vapor compression. So propane refrigerant here, air-cooled condenser, and then we have inside some ethylene glycol with some water mixture there. Is the coolant. There's a 1/4-inch copper tubing for the evap. Now I pulled up the unit there so I could actually see the coil, and it is frozen up. So my heat transfer area has diminished substantially. The ice, the slush that's formed on the evaporator, has caused the evaporator to become insulated. So any refrigerant that's moved into the evaporator, very much less of it is actually being evaporated, and it's being done so at a very, very low pressure. We're at about 10 pounds per square inch, where we were running at 40 or 50 before. So what's happening, if I understand this correctly, is that even though we're not getting slugging back at this point, the total mass flow through the system has diminished substantially. A couple of reasons I believe that's to be the case. For one thing, my compression ratio has risen. Even though my head pressure has dropped a good bit, I'm not moving a lot of heat on the back end there. In theory, what's happening is, because the suction pressure is so low, because there's not enough heat being supplied to the evaporator, that the pressure drops, because not very much refrigerant is being evaporated. The density of that gas, or that vapor that's returning to the compressor, is very low. So the total amount of mass flow is reduced in the compressor because the volumetric ratio is diminished. The gas is more rarefied when it comes in, so every time the piston has a cycle, less gas is drawn in, less total mass of gas is drawn in each time it does a suction. As it discharges and then goes to re-intake, it takes more of the stroke before it actually starts to return any substantial amount of refrigerant into the compressor. And then on the discharge, it's not moving as much mass, the head pressure doesn't rise as much, the temperature difference between the condenser itself and the ambient air in here, which has cooled off substantially since the last video, really doesn't account entirely for the fact that we don't have much of a temperature difference there. We're not moving that much heat. Also, with the pressure differential where it is right now, it diminishes the amount of mass flow through the capillary tube. So there's a lot of reasons why we're moving less refrigerant, we're moving less heat. The temperature difference between the evaporator and the coolant is fairly high right now. We got -21 evap temp, and that's approximately what my saturation chart would tell me, to the 16-degree coolant. In addition to that, we don't have a lot of surface area between the surface area of the bucket and the air inside the freezer itself, but I don't think that's as large of a factor as the very, very low pressure on the suction end of things. So as I explained, I'm going to get a better mix of coolant in there, try to avoid that slushing up and that freezing, because that really ruins everything. But I just thought I'd do a little video on it to kind of demonstrate some of the concepts of mass flow and volumetric efficiency. So, anyhow, I'm going to shut the thing down for tonight, and as soon as I get some better mix of coolant, I'm going to try it all over again, and try to demonstrate some effective operation over the entire temperature range. I was doing a little bit of blocking of the airflow here on the condenser to try to raise the high side pressure to move more refrigerant into the low side and get the pressure up a little bit, but it's really not even effective at this point. There's not much point in doing it because the evaporator is so frozen up. So we're pretty much done for this evening. But all in all, it's been pretty successful, and it's been a lot of fun to play with. I will continue with it for some time to come, and eventually I will be redoing the evaporator that's in this thing, making something that's probably at least twice the surface area that thing has, to reduce the temperature difference between the evaporator and the coolant, to reduce the tendency for it to freeze, so I don't have to go for a very, very strong coolant mix. And it also allows me to keep my suction pressure up, keep the compression ratio low, increase volumetric efficiency, increase mass flow through the compressor, maintain a reasonable amount of head pressure to keep the mass flow through the capillary tube, and eventually kind of get the thing tweaked to the point where I feel like I can do some reasonable tests on the amount of heat that I'm moving, even adding a heating element to the inside of the fridge, getting a baseline first and then eventually adding a heating element so that I can kind of get a better idea how much heat is being moved. And then beyond that, in the near future, I would like to switch over to a static condenser of all things, because that's my long-term goal is to move towards static condensers and a static evaporator, such that I don't have to rely on movement of air so much. But that's coming down the road. So, anywho, thanks for watching.